Hi everyone. Today we'll be looking at the states of matter. This is one of the most basic concepts in chemistry, but it'll prove to be useful when learning many future topics. There are three states of matter: solids, liquids, and gases. In solids, the particles have a regular arrangement and are tightly packed together. As you can see in the diagram, the formation of the particles is repeated and is the same throughout the solid, and the space between the particles is very small. This is because the forces of attraction between the particles are very strong, therefore holding the particles close together and in a regular arrangement. The particles in a solid cannot move. They can only vibrate in a fixed position. The particles in a solid have the least energy when compared to liquids and gases. In liquids, the particles have an irregular arrangement and are further apart from each other. This is because the intermolecular forces of attraction between the particles are weaker than those in a solid. This allows the particles to move around each other. As you can see in the diagram, the particles are still relatively close together, but they can move around more freely than in a solid. Particles in a liquid have more energy than those in a solid, but less than those in a gas. In gases, the particles have almost no arrangement whatsoever and have very large spaces between them. This is because there is almost no intermolecular forces of attraction between the particles in a gas. The particles can move freely and in random directions at different speeds. This can be seen by the arrows in the diagram. Particles in a gas have the most energy when compared to the other two states of matter. We will now take a closer look at the movement of the particles when in the three different states of matter. In solids, as you can see, the particles can only vibrate in a fixed position. In liquids, the particles can move around each other but are still kept relatively close together. In gases, the particles move erratically in different directions at different speeds. This is mainly due to the difference in the strength of intermolecular forces between particles in the three states of matter. We will now look at the changes between the states of matter. The diagram on screen shows the conversions between the three states of matter. From solid to liquid is melting, like when ice melts to form water. From liquid to gas is vaporization, like when you boil water. But it can also be evaporation. This is because the changing from liquid to gas is always taking place, just very gradually. This occurs because the particles in liquids have different amounts of energy. Those with more kinetic energy can break free and turn into a gas. Therefore, liquids to gas conversion is always taking place. Gas to liquid is condensation. For example, the water on your window when the window is cold. Liquid to solid is freezing, when you put water in the freezer and it becomes ice. Changing from solid to gas is called sublimation, an example being dry ice, which is just solid carbon dioxide. And changing from gas to solid is called deposition. Changing matter from solid to liquid and then gas requires energy because the intermolecular forces of attraction between the particles have to be weakened and or overcome. This is why gases have more energy than liquids, which have more energy than solids. And this is also why melting and vaporization requires heating. Changing matter from gases to liquids and then solids actually releases energy because when the intermolecular forces of attraction are formed, it releases energy. This is why condensation and freezing requires the substance to be cooled. The next concept we'll look at is very important, and it's diffusion. Diffusion is an incredibly important concept that involves fluids. It is a process that is used in many different larger cycles in all of the natural sciences: biology, chemistry, and physics. A fluid is a liquid or a gas. Diffusion is the movement of fluid particles from an area of high concentration to an area of low concentration. Diffusion will continue to occur until the particles are equally spread throughout the area. This is a very common practical experiment used to illustrate diffusion. A drop of blue dye, in this case, is added to a cup of water. The cup is then left alone. As you can see, the dye starts to spread throughout the water, coloring the entire solution blue. In the final image, it can be seen that the entire solution is almost a uniform shade of blue, indicating that the dye is spread evenly throughout the water. This is only one example of diffusion. There are countless other ones too. For example, if perfume was to be sprayed in one corner of a room, after some time the people at the opposite corner of the room would be able to smell the perfume, because the perfume will diffuse from where it is sprayed, an area of high concentration, to the other parts of the room, an area of low concentration. Going back to the diffusion practical we looked at, the colored liquid formed by adding the dye is a solution. A solution is a liquid that consists of a solvent and a solute. Solvent is the liquid base in which the solute is dissolved, as you can see in this diagram. And the solute, obviously, is the substance that is dissolved in the solvent. Once enough solute is added to the solution becomes saturated. This means that no more of the solute can dissolve in the solvent at that specific temperature. The solution is only saturated at that specific temperature because if the temperature is changed, the solubility of the solute will change too. Solubility is the ability of a solute to be dissolved in a solvent, usually water. This change in solubility with temperature can be seen in this graph. As temperature increases, the solubility of the solute in water, in this example, also increases. This is because as temperature increases, kinetic energy also increases, and this allows the solvent to break down the solute bonds with greater ease, therefore allowing the solute to dissolve more easily.